Hey guys, what's up? So in this video we'll be talking about capacitors, what they are, what they do, maybe a tear down and how to perform basic calculations. Whatever. Yeah, so capacitors are passive components with two electric terminals used to store electrostatic energy in an electric circuit. So they usually consist of two, yeah, I say usually because it could change, of two electric conductors, maybe plates, separated by a dielectric. So when there is potential difference across the two terminals of your capacitor or voltage across it, an electric field builds up across the dielectric between the two plates, which is usually an insulator, and thus one plate accumulates positive charges while the other accumulates negative charges. So how much charge your capacitor can store, how much of these charges your capacitor can store is described as the capacitance of the capacitor, measured in farads. On your capacitor or these average capacitors, you usually see it as microfarads, right? Okay, sorry. When you usually see it as, for example, this is 470 microfarads. Yeah, so, and this capacitance now is the ratio of the charges on this conductor to the potential difference across the two terminals, right? That is, it is the same amount of these charges over the potential difference, right? And the amount of charge here now is also related to the distance between these two plates, right, and the size of the plates themselves. So let me open up this capacitor real quick just to show you the two plates and the dielectric between them, and then we'll be moving on. So I decided to just show you this. First of all, we have this let me say nylon coating or plastic coating on the capacitor itself. Right. So yeah, then we have this metallic coating. I know that is just the container of the capacitor. And then he also says this rubber stuff. It's all just part of the insulation and we are going to protect you. Yeah, so we have that. And then this is the actual capacitor. Looking at it, there seems to be kind of like a liquid or maybe to be honest, I really don't know what that does now. Basically, I'm not just going to open it up, and you can see this is the dielectric, actually, the paper. Okay, and then yeah, this is the first plate. So we just open it up. And there you have it. See that the first terminal connected to one of the plates, separated with the dielectric, in this case paper, and we have the second terminal connected to the second plate. So why we have two dielectrics is because this is going to be rolled up, right? Yeah, so you can see the plate here actually has a larger surface area, right? So it's bigger and it can store more charges. So there we have it, capacitor tear down. Yeah, now so uses for capacitor, in your circuits. Although as we go along, you actually learn more, and then you can check more online. But basically, you can use capacitors to filter out direct currents while allowing alternating currents to pass. You can use it to filter signals when you are working with ICs to certain pins. You can use it to smooth out the output. For example, you can use it to smooth out the output of an inverter, and also in your fans. Yeah, the capacitors in your fans are used to smooth out the electricity going or current going to the motor wherever. And then one particular example is in your radios now. You try to adjust it and get a particular frequency. Capacitors are actually also very much involved in that. Yeah, so now we'll be wrapping up with a few calculations to calculate how much charge a capacitor can store or stores, stuff like that. Yeah, so moving on from this little relation we have here, the basic formula let's see, in the capacitor will be C or Q. Let me use Q is equal to F times V, right? Where Q is the quantity of charge, F is the capacitance, and V is the voltage. You would usually find these two on the body of your capacitor. Electrolytic capacitors now, I guess, yeah, you usually find it. Say in our case, we just tore down a 35 volts 450 microfarad capacitor. Yeah, so to store, like, say 1 coulomb of charge, you simply divide that 1 coulomb, just like over here, with how much voltage or is across potential difference across the dielectric. So let's say 10 volts or 9 volts. 9 volts, yeah, because of the 9-volt battery. So in that case, a minute, yeah, it's actually 0.111 to infinity farads. And just to wrap it up, I actually found this cool formula, and I'm still going to research it myself online while doing a little bit of recon. Yeah, just when learning about capacitors. And it says that the energy in a capacitor is 0.5 times the capacitance. In this case, let me use F times the voltage squared, right? Yeah, that's how much energy is stored in the capacitor. So yeah, see you.